You will revisit this a lot, primarily in pre-cal and then in calculus and beyond. So not so much, you won't really see it in Algebra 2, but you will see this topic a lot in pre-cal and calculus. So just to give you a little bit of background. So this is actually on your notes, but I wanted to give you the background behind it. So this word trigonometry, of course, I have to tell you that it comes from Greek root words, being Greek and all. So it comes from, if I pull this apart and I look at this, and I split that into tri, or tria for 3 in Greek. So that is 3. This tri means 3. This gonon or gonia means angle in Greek, or corner. And then if I look at this metri, it comes from the Greek words metron, which is measure. So if I put that all together, that word means literally 3 angle measures. So 3 angles should make you think of triangle measure or measurement. So trigonometry is really the study of triangle, the 3 angle measures. Yes.
Wait, metron.
Metron, yeah. Okay, so I mean, you know, that's why it's helpful to know Greek, because, you know, you can read these words and kind of get a little understanding of it. So what we're really looking at is we're looking at ways to find the measure of angles within a triangle. So we're going to focus our attention to right triangles. So if I look at this right triangle down here, I have a right triangle. Okay, so it's a right triangle. Now, if I look at the pieces of this triangle, we have already discussed the hypotenuse. The hypotenuse is the longest edge in the right triangle. We studied the Pythagorean theorem. That's C. Now, how am I going to look at finding the measure of angles? Well, in mathematics, they like to look at and call an angle that we're interested in as theta. So this little symbol here is it's the Greek letter theta. So if I'm trying to figure out what this angle measure is, this angle I'm going to call theta, the way I'm going to find it is, one way to find it, I should say, is by looking at the opposite side length over the adjacent side length. And by looking at that ratio, I'm going to be able to find the degree measure by just looking at that value of the length of the opposite side over the value of the length of the adjacent side. That ratio is known as tangent. Okay? Now, there are other ways to find degree measures. In fact, if we look at trigonometry, we will be studying what's known as sine, and that will be opposite over hypotenuse. Cosine, which we will study, next week, and cosine is adjacent over hypotenuse. But what we're going to focus on today is tangent. And tangent is found by taking opposite over adjacent. Yes, ma'am.
So it's adjacent is always the one that's like the other one.
It's right next to you. Adjacent means it's right next to you. It's not opposite, it's right next to you. Now, we never use the hypotenuse when we're talking about opposite and adjacent. So that's key. So before I wanted to start working with tangent, I wanted to give you an idea of what tangent really is. It's just a ratio to help us find the degree measure of an angle using the pieces of a right triangle. Does that make sense? So we will look at sine and we will look at cosine next week. Today, we are focusing on tangent. Okay? So let's go ahead and do that. So as we said, trigonometry can be broken down into triangle measure, finding the measure of an angle in a triangle. As we just saw, one method to find a degree measure is to use the trigonometric ratio of the lengths of two sides of a right triangle. Today we are focusing on the trigonometric ratio, the tangent ratio. So the tangent of an angle, and I added this as well, the tangent of an angle is obtained, the measure of an angle by using the tangent of that angle is obtained by looking at the opposite of an angle, the opposite leg, over the adjacent leg. So if I'm looking for, let's say, the measure of angle A, that's our little theta. So if I'm looking for this measure of angle A, I'm going to look at the tangent, and it's written in small hand as tan A of what? If I look at opposite is A, adjacent is B. So that's if I'm looking at the tan of measure of angle A. Now, if I'm looking at the tangent of angle B, so now I'm trying to not calculate A, I'm looking to calculate B. To find B, I look at opposite of B. So if I'm trying to find B, what's the leg opposite of B? I mean, yeah, well, it's obvious here. B over adjacent, which is A. So again, tangent, the tangent ratio is just the ratio of the opposite leg, and opposite is with respect to the angle, right? Opposite that angle over adjacent of that angle. Opposite over the angle, adjacent over the angle. And again, it depends on which angle we are really trying to find. So let's do a few examples. We're going to write the ratio, and then we're going to simplify it or convert it to a decimal, rounded to 4 decimal places. So given this triangle, we are looking for the tangent of A. So if I'm looking for the tangent of A, what is the opposite of angle A? What length is opposite of angle A? 3. What is adjacent over angle A? 4. And if I were to convert that to a decimal, what would it be? 0.75, right? It's not a whole, quite a whole. That's okay. So I would say the tangent of angle A is 0.75. You can either write it with or without the parentheses. The reason I'm kind of putting the parentheses there is because tangent is a function. It's a rule. We're doing something to A. What are we doing to A? We're looking at the opposite over the adjacent. So it's actually the input to a trigonometric function, yes. So if I'm looking at A, this is my opposite, and then adjacent to this angle, and remember we can't use the hypotenuse, adjacent would be this. This would be the leg that is touching, that is adjacent, that is next to angle A. You can never use the hypotenuse, and let me just, I really like that you said that. Never use hypotenuse with tangent. It's only opposite over adjacent. Okay, so now let's try to find the tangent of angle B. So if this is angle B, the tangent of B would be, well, what's the opposite of angle B, the opposite leg? 4 over the adjacent 3. And then, well, 4 divided by 3 is approximately what? And the 3 is repeating, right? So I can just put that bar, the little vinculum over the 3, right? To designate that it's being repeated. Yes.
So you always have like.
For our practical purposes, we should be simplifying. We should be very well. Actually, 0.75 is not any more simplified than 3/4. It's just converted to another format, decimal format. But if it can be simplified, let's say we had 4/2. You go ahead and simplify that to 2. Yeah. Yes. Yes, and we're going to talk about that. Yes, ma'am. Because this is exactly, good question, this is exactly 0.75 if I were to divide 3 by 4. If I were to divide 4 by 3, this goes on forever and ever and ever and ever. So this is only a mere approximation of 4/3. It's not a finite decimal. It keeps going. It repeats. So it's therefore I'm approximating by saying it's 0.3 repeating. Good question. All right. Now, what happens if I have the angle measure? And I want to maybe use the fact that tan is obtained by opposite over adjacent to maybe work backwards. So I have the angle. Can I take the tan of that angle and maybe find the length of the sides? Well, in this case, we have one of those very special triangles. What type of triangle is this? It's a 45, 45, 90 triangle, which means it's what type of triangle? More specifically, a right isosceles triangle. Excellent. This is a right isosceles triangle. It's a 45, 45, 90 triangle. It's one of those special ones. So we should know the relationship among the sides of those triangles with respect to x. If we were to represent this, the two legs would be what? They would each be x. And just for kicks, as a reminder, even though we're not really using hypotenuse right now, what is the length of the hypotenuse in terms of x? X times the square root of 2, right? Okay, now I know the tan of 45. So the tan of 45, and it doesn't matter whether I use this 45 or this 45, I'm going to get the same ratio. The tan of either one of those angles is the opposite in terms of x over the adjacent. So it doesn't matter what that x value is. We know for a right isosceles triangle, those two x values are the same. They're congruent. So any number other than 0 over itself reduces to what? 1. So we know that the tan of 45 degrees equals 1. It will always be 1 in this case. Tan of 45 degrees, that's a fact, will always be 1. Now, what happens if it gets a little bit more interesting? In other words, oh, we don't have one of those special isosceles triangles. So in this case, we do have an angle measure. I do have some information to be able to set up a ratio. So it would be the tan of 43 degrees equals what? Opposite over adjacent would be what ratio? X over 24. Now, how am I going to solve for X? Well, can't I just write this as a proportion, a ratio set equal to a ratio? And how would I solve for X? I would cross multiply. So if I multiply these two together, I would get 24 times the tangent of 43 degrees equals X. Now, the tangent of 43 degrees is just going to be a number. It's just going to be a constant. And I can multiply that number by 24 to find out the length of X. Back in the olden days, when I was in school even, we had tables of values. In other words, we had these huge tables that said tangent of 1 degree, 2 degrees, 3 degrees, 4 degrees, and it gave me the decimal equivalents. But what happens if you don't have those tables? You have a calculator, and the calculator knows how to calculate the tangent of different angles. So do you have your calculators with you? Let's go ahead and get those out. We are going to calculate tan of 43 and multiply it by 24. So to do that, I'm going to have to quit the screen, so forgive me for a moment so I can share my other screen. And we're going to get our calculators out, and I'm going to share this screen here. If I can get my calculator open. Oh, heavens. Slowly but surely. There we go. And I want you to focus your attention here. What do you see? You see those 3 trigonometric ratios that I mentioned to you. You see sine, cosine, and tangent. They're abbreviated as, well, sin, cos, and tan. But that is an abbreviation for sine, which is a ratio, cosine, which is a ratio, tangent, which is a ratio. Tangent is opposite over adjacent. We have that. So we are calculating tan of what angle measure? 43. So you don't have to put the degree measures. Now, before we move forward, your calculator should already be set to work in degrees. But on the off chance that it isn't, or as you get into future math, you may have to switch back and forth. Let's just go back and make sure we are in degrees. Go to mode. If you go down, we should be in math print, normal, float. Those are types of numbers that you're working with. If you are in radians, meaning this is highlighted, arrow to the right and highlight degree. Is anybody in radians? Ooh, let's switch to degrees. Otherwise, you're finding you're working in the tan of 43 radians. Ooh, and that's totally different. And you will work with radians, but not until pre-cal. Okay, so that's why we have to be able to switch back and forth between these. So now we've switched to degree. Hit enter so that we actually are working in degrees. So is everybody in degrees? Then hit second mode, which is quit, and go back to the screen. So we have entered in tan of 43 degrees. Get in the habit of closing your parentheses. Technically, the calculator knows to do that, but as these problems get a little bit more interesting, for example, we're going to have to multiply this by 24, right? I think it was. So let's go ahead for kicks and evaluate that. Do you get this value? Yes? Now, that is the tangent of 43 degrees. So what does that tell you? The tangent of 43 degrees. But does that tell you x? No, because we have to multiply that by 24. Now, could I have entered 24 times the tangent of 43 degrees? Would I have gotten the same thing? Yes. So you can't do all at once. And it might not be a bad idea to do that because we really don't want to get rounding errors, right? So like if you had taken 22.3 and then multiplied that by 20 down the road, we want to be careful. So what do you think this represents now, this numerical value we have just found? We have just found x. So x, that length, is 22.4. Does that make sense? Yes, sure it does. So let's go back. And we now have found that x is approximately 22.4. Yes. I'm sorry. Yes, let me switch. There we go. Now, let's try the next one. So this is all about tangent, but in the future, you will have to figure out which ratio, which trigonometric ratio you're going to need to be able to solve for the unknown value. Today, we're working with tangent. We have this angle measure, so we're saying the tangent of 32 degrees equals, and what is the ratio? How would I write the ratio of opposite over adjacent? 12 over y. So again, to solve for y, I have, in this case, y equals the tangent of 30, degrees equal, oh no. How am I going to solve for y? This is just a constant, right? That's just a value, that's just a number, right? So can't I divide each side by whatever that is? So that I have y equals 12 divided by the tangent of 32 degrees. Now that's not good enough. I need a numerical value. So let's see how we're going to go ahead and put that in the calculator. Okay, how do you think we're going to do that? Okay, well, yes. So that would be 12. Am I sharing? Yes. 12 divided by, now I'm going to divide by this entire value. So I'm going to put it in parentheses because I like to put more parentheses than sometimes is even needed. Tan of 32. And then I need to close that parentheses. And what did y'all get? There we go. Excellent. Back and forth, back and forth. And does that make sense? Sure. Now, from there, if we really wanted to, couldn't we get the length of the hypotenuse? How would we do that? Pythagorean theorem. 12 squared plus 19.2 squared, and we could get the hypotenuse. Now, we talked about the calculator instructions to find measurements, lengths, but what happens if I want to find the measure of the angle? So I don't know the angle. I'm looking at the missing angle. Well, we know the tangent of an angle equals the opposite side over the adjacent side. So you're going to have to take a little bit of a leap of faith here. If I'm trying to isolate the angle, and this may be a huge stretch for y'all, because I don't really know how much you know in terms of the algebra. So I'm trying to isolate this. So let's just think of this as 4x equal y. Let's just say that. If I want to solve for x, and I'm going this route because I want you to be thinking this way for when you get to Honors Algebra 2, because this is going to be huge. If I want to solve for x, what do I have to do to isolate the x? I have to do the opposite operation of how that 4 is connected to the x. Now, 4 is connected to the x by what operation? Multiplication. So you may say, oh, I just need to divide each side by 4. Could I not multiply each side? Let me do that in a different color. Could I not multiply each side by 1/4? Isn't that the same thing? Now, 1/4 is the reciprocal, is the inverse of 4. Are you with me? Another way to represent the fraction 1/4, and again, this may be a leap depending on what you know with exponents. 1/4 can be represented as 4 to the -1 power. Who has seen that before? Okay, you've seen that. Are you with me? So 1/4 can be represented as 4 to the -1 power. So 4 to the -1 power is known as the inverse of 4. The inverse of 4, the reciprocal of 4. Right? These two are reciprocals. Those two are inverses, right? 1/4 is the inverse of 4. 1/4 can be represented as 4 to the -1 power. Now, the reason I bring that up is because to solve for this angle, I have to get rid of that tangent. Now, technically, that tangent isn't multiplied by the angle. The angle is the input to the tangent. So to get rid of the tangent, I'm still going to go along the same process, and I'm going to multiply it by the inverse of tan. Because tan times its inverse goes away. It becomes 1, so to speak. We're kind of undoing taking the tangent. We're just like we undid the multiplication of 4 here, we're undoing this tangent. That's exactly right. That is exactly right. That is exactly right. So now the angle becomes, like you said, and it's read as the inverse tan of the opposite over the adjacent. And guess what? Right above that tangent button is the inverse tan. Okay? So let's go ahead and try an example. We are looking for the measure of angle. Let's say the two angles we're looking at are angle A. We want to know what angle A is. And we want to know the measure of angle B. Okay, so we're going to do two separate problems. So if I want to find the measure of angle A using our tangent trigonometric ratio, I would say the tangent of angle A is what? 5/12. So to solve for A, I would be taking the inverse tan of 5/12, right? Because technically I'm doing the inverse tan here and the inverse tan here. Say that again. T.
And then I have that T.
I have to look at what you're looking at, and I will answer that question. Just remind me, okay? I will answer that question. Can we set up the ratio to find the measure of angle B? What would that be? 12/5, right? So then B would be the inverse tan of 12/5. So now we're going to put each of these into the calculator, and we're going to find them. So let's go ahead and do that.
How do you do the inverse?
I'm going to show you. Okay. So if you look above the sine, cosine, and tangent, do you see the inverse of each of these functions? Each of these. Yes? Okay. So to put this in the calculator, I would literally, for the first one, say second tan. So the little blue above it is obtained by hitting the second button. Can we get the inverse tan? Of, and what did we say? 5/12. So 5 divided by 12. And I'm going to close the parentheses. And lo and behold, there's our degree measure. So the inverse tan of 5/12, the measure of angle A is approximately 22.6 degrees. So now you find me the measure of angle B based on the inverse tan. You find it. I'll do it at the same time, and let's see if we get the same answer. What did you get? Yay! Excellent. Okay. Well, 1 decimal place is sufficient unless on the test or anywhere it says round to the nearest, you know, tenths, hundredths, thousandths place. 1 is fine for me. That would be fine for me. Okay, so just for completion, let's go ahead and say that the measure, the measure of angle A is 22.6 degrees approximately, and the measure of angle B is approximately 67.4 degrees. That's it. So there's tan. So next week we're going to work with sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, and we know tan. And a little foreshadowing, the way most people are introduced to these 3 trigonometric functions, because, you know, I'm going to give you something to think about over the weekend, is SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over hypotenuse. Have y'all heard that before? There it is. All right, y'all can work on your homework, and let me answer your question about what you saw, and then I will post.
I'm confused what this is.